Lateral magnification is also known as the transverse magnification, and it is defined as m equal to h2 by h1, where h2 is the length of image and h1 is the length, or we can say size of object. Now we have to find this magnification in terms of the u and v, that is the distance of the object and image. Let's consider a mirror, say concave mirror, whose principal axis passes through the pole and the center of curvature. Suppose an object is taken AB, which is perpendicular to the principal axis. We take two rays from the point B. Suppose one ray is incident directly at the pole. So if angle of incidence is theta, because the line joining the center of curvature and the mirror is normal to the mirror, therefore CP is the normal and the reflected ray will be at the same angle. This is the first ray of reflection. Now we consider another ray which passes through the center of curvature. Because we have already mentioned this, that the line joining the center of curvature and the point on the mirror is normal to the mirror at that point. So ray reflected back onto the same path. Therefore, we get the intersection of the two reflected rays, and this intersection point is the image of point B. And if we draw the normal onto the principal axis, we get the image A dash of the point A, and we get the image A dash B dash of the object AB. Now we consider two triangles A, B, P and triangle A dash, B dash, P. One of the triangle is ABP, another triangle is A dash, B dash, P. In this triangle, angle BPA equal to angle B dash PA, that is equal to theta, given by the angle of reflection equal to angle of incidence. Similarly, angle BAP is equal to angle B dash A dash P, and these two angles are the right angles, that is 90 degree. Therefore, third angle is equal, and in similar triangle, all three angles are equal. Therefore, we can say triangle ABP and triangle A dash B dash P are similar triangle. This implies that the ratio of the corresponding sides will be equal. Hence, we can write that AB by A dash B dash will equal to AP by A dash B, or A dash B dash by AB equal to A dash P by AP if we invert. Now substituting this value in the equation, A dash B dash is the length of the image, and it is because inverted, that is below the principal axis, therefore it is taken negative as per the sign convention. Hence A dash B dash is minus h2. AB is the length of object, it is above the principal axis, so taken positive, it is h1. AP is the distance of the object from the pole on the left, and it is on the left hand side, so it is minus u. And A dash P is the distance of the image from the pole and is on left hand side, so it is minus v. Substituting the values, we will have minus h2 by h1 equal to minus v by minus u. Hence, finally we can write that m equal to, which is the magnification, h2 by h1, that is equal to, using the above equation we can write it is equal to minus V by U. So this is the lateral magnification or the transverse magnification. And this formula is also valid for the other situations and the convex mirror.